Right, addressing some of the questions that you have from Refraction Tutorial 1. First question is on question number 2. Now, because we have not learned how to calculate the angle of incidence and angle of refraction, so we are not able to draw accurate ray diagrams to scale. So we are only making use of the fact that when your light ray travels from optically less dense medium like your air into an optically denser medium like your glass, then the light ray will bend towards the normal. And when it is traveling from an optically denser medium like water to optically less dense medium like air, the light ray will bend away from the normal. But we are not having the exact angles of how much to bend away or towards the normal, so we just draw an estimated diagram there. So for this particular question, okay, you have the light ray moving from glass into air. So the light ray will bend away from the normal because air is optically less dense. But when it is traveling from air to water, okay, less dense to denser medium, the light ray will bend towards the normal. However, we note that this part is glass. Glass has a higher refractive index than water. So the angle that the incident ray makes with the normal for glass will be smaller. It's like bending more towards the normal. And then for this light ray, the angle made with the normal is slightly bigger than angle Y here. Okay, because even though it bends towards the normal, it doesn't bend as much as when it is bending in glass. Okay, the other question that was raised is this one. Okay, I think most of you were able to do. Those who can't because you are not able to see your normal properly. Okay, so because your light ray is coming at this angle, okay, and your surface here is slanting, so it will be good if you cannot visualize it. You may want to turn it such that this becomes a horizontal line, and then you draw your perpendicular line to your glass surface to get your normal first. Okay, then you can see it this way, that when you're traveling from air into glass, the light ray will bend towards the normal. Okay, then you turn your paper around, this glass surface here, make it a horizontal line, then you draw your perpendicular line to it to get your normal. Okay, then now you can see that when the light ray is moving out from glass into air, it bends away from the normal. Next question is question 4b part 3. Okay, you're supposed to determine the angle of incidence I at O. Okay, remember the angle of incidence is the angle made by the incident ray with the normal, not the glass surface. Okay, so angle I is here. So you need to take 90 degrees to minus your 25 degrees in order to get your answer 65 degrees. And then after that, you should have no problem when moving from water to glass. Glass have a higher refractive index than water. It's optically denser, so the light ray will bend towards the normal. Question 4c, someone asked how to calculate the speed of light in any medium. You make use of this formula, okay, where n is the refractive index, c is the speed of light in vacuum, and v is the speed of light in the medium itself. So you rearrange the formula, you get v equals to c over n, and then you just substitute in the values to give you your speed of light. Then the other question that most of you asked was this, rounding up to 3 SF, shouldn't it be 2.26? Yes, for this case, if you are using 1.33 in your calculation, you get 2.255 something. So your answer should be 2.26. Okay. However, if you are using the refractive index Okay, the actual refractive index 1.3333333, carry on, then you end up with the speed is actually 2.25. So both answers are accepted in this case. Okay, somebody asked about not sure how to draw the direction of the rays. So let's say we have your incident ray coming from your air into water. Okay, so by right, if there is no refraction, the light ray will go this way. Okay, so but we know that from air, which is a optically less dense medium, to water, which is optically denser medium, the light ray is going to bend towards the normal. So it will come towards, see, this is the normal. So you come towards the normal, this direction, right? But if you are moving from water to air, denser to less dense, so by right, if without bending, the light ray goes this way. Okay, so now you want to bend away from the normal. So this is the normal. You're going to bend further away from the normal. So it's going to go in this direction. Okay, so that is what it means by bending towards or away. So just look at your normal and see where it bends to.